For this YKEP, let's start at the compressor and let's work our way through from there on this refrigeration cycle. We're going to go over the basic cycle here. So coming into our compressor, we have our PRV. We go through the impeller assembly, through the compressor into our discharge or our volute. It's also known as the scroll housing. That discharges into the top of our condenser. There's a set of baffleting up here that helps distribute that superheated discharge gas across the length of our condenser barrel. That's then going to send the refrigerant across our condenser water tubes. Water is going to be flowing through the inside of our tubes, refrigerant on the outside. As the refrigerant condenses into the water, takes the heat in, then we're going to drain the saturated liquid refrigerant down into the bottom. Now, this particular heat exchanger has a subcooler section, so we actually do maintain a bit of liquid level in this chiller, and then we will flow through our subcooler bundle to get a few degrees of subcooling out of it before we pass on to our liquid line. It is important, just like with a regular YK, that we maintain appropriate liquid levels, and this chiller is very much a lot of the best things about what makes the YK great, but now we have our new section of it, which is our economizer. So flowing into our liquid line, we go through some isolation valves, and we have our first orifice. It's a variable orifice valve, just like we see with the YKs, where we can control how much flow goes into our economizer. Now, this valve specifically controls based off of the condenser liquid level, just like we see with a regular YK. So this first valve, the first stage of flashing for our pressure drop, is actually going to react and work just like we would expect to see with a standard YK machine, or pretty close to it. But from there, something does happen a little bit differently. We don't go straight into our low pressure state. We actually go into a medium pressure state where part of our refrigerant is flashing off and getting drawn into our economizer compressor, and the other part of it is getting the liquid piece of it specifically is getting sent into our second stage of pressure drop or flash, which is our it's another variable orifice valve, just a butterfly valve. It's slightly modified. That valve also controls based off of the economizer liquid level. So we're taking a similar concept that we're doing on the condenser with liquid level, but we're also doing it in the economizer, and that's how those two valves are controlled. Then we go into our evaporator. Now, this is a flooded evaporator. So with a lot of YKs, especially the most recent ones, we're seeing a lot more of the hybrid falling film and flooded design. Well, this one is using a flooded evaporator. So all of our tubes in the bottom are fully submerged in liquid refrigerant, helps really improve our overall efficiency while keeping our footprint down to a minimum. And then we go through this eliminator as we boil off and the refrigerant takes in heat from our chill water loop. As the refrigerant's boiling, there's a lot of turbulence and just kind of bouncing around. If you've ever seen inside of a sight glass of one of these, with everything going, that boiling effect, there's a lot of droplets. So we have an eliminator in the refrigerant stream that's able to take a screen mesh and quite literally just helps eliminate and prevent all those heavy refrigerant droplets from being able to get pulled into the suction gas stream. Now, this suction gas, just like with most centrifugals, is at saturated vapor, so it's not superheated or anything of that nature. We're just getting it to the point of saturation, to the point of being a vapor, half a degree, 1 degree or so of superheat. By having this mesh, which is also known as an eliminator, we help prevent any liquid getting to our impeller, which is really bad for these aluminum impellers. Anyway, that flows up into our suction elbow, back into our compressor. Now, back over here at the economizer, that flash gas off this first stage of flash, now this is, again, a medium pressure, gets pulled into our economizer compressor. This is another centrifugal compressor, just a much smaller one compared to our primary compressor. This compressor will then just compress that gas and get it back into our condenser side, and then it recirculates further from there. It doesn't go anywhere else, just straight from the economizer through that economizer compressor and then back into our condenser. Now I'm going to go into our economizer function and how that works in a separate video. We're going to go through that in detail, so be looking out for that. But this is just a basic pressure enthalpy chart of what that pressure cycle looks like inside of this machine. Now there's one extra component that is optional, for this machine, and that is a hot gas bypass. So if you needed help getting further capacity control and further load unloading ability at lower load states, then we could have a hot gas bypass option included in this machine. Or I say we, York, I'm not with York. But either way, you can order this as one of the options. It is not there unless it is specifically specified in the order process. So this is just going to be an extra feature, but ultimately what this is taking hot gas refrigerant, passing it over, and doing it in a metered way. It's not just to open a valve and let it flow, but we're metering how much gas is able to go through here, and this helps lower our lift, lower our capacity, even though our compressor itself may be at its minimum that it can possibly process already. So we can't unload the compressor further, but we can open this hot gas bypass and reduce a little bit more capacity on it. These are pretty interesting machines. They are right now being serviced in the much larger tonnages. So I think the ones I've seen are 2,500 tons. I'm not sure what all ranges York is going to end up producing these in just yet, but I do know that they're really targeting more of that larger industrial audience. And I'd really like you to have to stop struggling with chillers, stop having a hard time, stop feeling alone in this journey and what you're trying to accomplish, and just be successful in your career. And I want to do that through chilleracademy.com. I've created a course I really wish I had when I got started, when I was trying to figure this stuff out. These are the things that we're going over in that course. Get in there, get into the community, ask your questions. Let me take you through the course and guide you through our whole process so that you come out confident and prepared to do your part and to succeed in your chiller career with that MTT. Make the time for your family, for your spouse, for your kids. I'll see you later.